So I will talk about the economics of green transition, zero growth and degrowth. So I'm more critical of zero growth and also of degrowth, but listen to my arguments. So what I want to do, I have to look at the clock. First, I focus, in contrast to the other presentations, not so much on abstract theory of zero growth in terms of models, no matter or what the drivers for zero growth really are. I look at, or I'm a bit disappointed with this kind of models because they are too much detached from reality and especially from from what is necessary to be done in the next 2 or 3 decades. Therefore, I focus on the green transition to tackle climate change. This is part of the big environmental problem, but a key part. So my first question is, can zero growth decarbonize the planet? You can guess already what my answer is. Then I come up in a very short summary of this section in my paper on the stylized facts on climate change. Then I talk about the economics of green transition. What does it mean and how can it go? How can it succeed? And after the transition, what will come then? Then I'm back at zero growth, degrowth, and steady state, and come to other conclusions than ecological economics. So many papers on zero growth detect or disconnect environmental analysis from the economic analysis. We experienced this in the first session today. So for some, zero growth is the key for prosperity. So zero growth is good for true prosperity of the people. This would mean that the level or the scale of output, say GDP per capita, it does not matter for the environment. I will make this clear. Compare 2 countries. You can guess which they are. One has $60,000 US GDP per capita, the other one has 10,000. It is USA and China presently in current dollars. Let's say both have zero growth from tomorrow on. Does it make sense to tell the Chinese to have zero growth, even though apparently the level of the output does not matter for sustainability? So if that is not the case, the Chinese, or if I were Chinese, I would say, let's have higher growth, let's have growth. So that's a logical contradiction. You can't say that zero growth is good for prosperity and also good for environmental sustainability if you exclude the level of output, and then therefore the structure of output and the consumption of natural resources, which are strongly determined by, nobody discusses this or refutes this, by the level of output. So therefore, the key issue for the planetary economics is now, when we talk about the climate change, to reach climate net zero or climate neutrality, as it is called nowadays, a bit misleading term, I would say, until 2045 or at the latest 2050. In order to limit the temperature, as you all know, to 1.5 plus 1.5 degree or maximum 2.2 degrees, although 2 degrees would even mean that tipping points could quite likely happen, are not excluded. So it means that the actual emission of greenhouse gas, GHG, would have to drop from 45 gigatons right now to 0 until 2015. So absolute decoupling. absolute decoupling. And if we don't have this absolute decoupling on the globe, then we will have the trend which goes towards 3 degrees. And that is the end of good living of mankind on this formerly blue planet. So this is green growth. If we need growth for it, and I believe we need growth to achieve this, not in general, all the time, but for this purpose. And that is a key issue, and nobody will dispute this. We need green growth. So if we follow this residual budget approach, which we have now from the International Panel on Climate Change, I guess you all know this. If there are 400 gigatons CO2 equivalents, including methane and other gases, left, more we cannot give into the atmosphere unless we want to violate the 1.5 or 2 degree goal, then we have only 9 years left, or 25 years if we're talking about the plus 2 degree Celsius goal, 9 years. So emissions, even if we had 0 growth on the globe from tomorrow onward, emissions will wreck the planet. 0 growth would wreck the planet. If the IPCC natural scientists are right, and I believe they are right, even though I can't judge on that, but I believe they are right. A little word just on net zero or 0. I think it should be 0. The alternatives would be that we have for some time negative emissions, which are absorbed then through, or where CO2 or other gases are absorbed by reforestation or by CCS. CCS is an unknown technology, very critical, and reforestation is not new, but in both cases, only a little bit of time would be bought, not more. So forests indeed absorb CO2, yes, but we can't increase forests on and on because land is scarce. And land is also in conflict with other uses, say for arable land for nutrition of perhaps 9 or 10 billion people on the globe. So let's assume net zero is really 0. Now, I jump into reality. Look at the additional GHG emissions since 1990 until the latest date that I found, 2018. We see that 57% come from China, and the next column is lower middle income countries, 27.6%. That is, half of this is India. And HIC is high income countries. In this case, without the US and the EU, is a smaller part, and some other upper middle income countries, UMIC, have only a small share. The US is practically 0, and EU is even in the negative. So it is mainly some emerging countries, mainly China. I don't like to bash China, but if we just look at the data, it's pretty clear that without China, changing something in China and other middle-income countries, we cannot tackle the climate change problem. Of course, without the US and the EU, we can't change either. So both is necessary. If we just, as a spotlight, look at electricity generation, 63 of it in 2019 is from fossil energy, mainly coal. If we look at primary energy consumption on the globe, 83% is fossil. If we look at the average carbon price, I take a number from McKinsey, I don't know whether it's a good number, but it's an estimation, it is $3 presently. It is almost nothing because there are so many subsidies in energy. So we need to decarbonize. So that is the greatest challenge we ever had in the history of mankind, as I see it. So how to do it? Now, first, some more stylized facts. What is the problem? It is the scarcity of sinks. The atmosphere is a sink, tropical forests, oceans, etc. But we have abundance of mineral, fossil metals under the ground, and they must be kept under the ground forever. It is precious. They are revalued as an environmental treasure if they are kept under the ground. That means we have to devalue them and disappropriate the owners of them. They should earn no cent of money with this because we don't need it, or we need it under the ground and not in order to burn it. So this is in contrast to much of what Georgescu Rogan said, that, and the Club of Rome long time ago, that the mineral resources or natural resources are waning, and in the end we come to zero growth or less than zero growth, negative growth, because these resources are exhausted. What is important now in the transition, it is not only the goal, but the speed is important, because it has to be done until 2045 or so. Otherwise, we emit too much into the atmosphere, which cannot be absorbed by the sinks. The cumulated growth of CO2 was since 1970 about 9% per year. These emissions, these GHG emissions, they accumulate. So they stay in the atmosphere for almost ever. So this means that roughly 52% of all fossils that have been burned so far since 1896, 52% came after 1991. And why this? Because of emerging economies mainly, and without change in the rich countries, or with very little change, not enough to come down from a very high level. So the GHG intensity per unit of GDP fell by roughly 1.3% per year since 1990, so that is an efficiency increase. On the other hand, we had population growth also of 1.3% on the globe in this period. And GDP rose by 2.9% per year on the globe. So growth is higher than the efficiency increase. And roughly half of the growth of GDP is due to population growth on the globe. So population growth is often in our debates about, and also in the previous presentations, was not a topic. So 60% of GHG emissions come from 10 large countries, and 53% of all the emissions come from China, US, EU, and India. If these four large emitters do not cooperate, we will never get there where we want to get. So it is also then a crisis of extractive capitalism, which lived from exploiting labor and from exploiting nature, mainly via fossil energies, mainly via coal. And it is a crisis of development strategy, not only in China, but also in other emerging economies, because it is based on being cheap, cheap, cheap. And in order to be cheap, you have to have cheap wages, but also cheap energy from under the ground. I just look at this little equation. Lowercase g here is the growth rate of emissions, of GHG emissions. Lowercase y is GDP growth, real GDP growth on the globe, and E is the efficiency increase, so the reduction in GHG intensity of G. If we want to tackle the greenhouse issue with lower growth, so reduce Y, then we could, for instance, reduce reduce global GDP to the level of 1994 with the efficiency that we have now in 2018. This would mean we halve GHG emissions to 23 gigatons, which would be emitted on and on further. This is mission impossible if we want to achieve 1.5 degree or the 2.0 degree goal. So degrowth cannot do it unless we want to have enormous degrowth close in the direction of zero global GDP, but let's not talk about that. E is not only a technology variable, the GHG intensity, it has to do with behavioral change. Because if I use the bicycle and not the car, it lowers the GHG intensity, and of course this is behavior. So what is the tradition? It is creative destruction, it is disinvestment of the old capital stock, and it is creating a new capital stock, and this requires net investment. The old capital stock, even if it is not yet fully depreciated, has to be replaced in full by a new capital stock. And even more than that, almost all products that we use, manufactured products, industrial products, or industry-made products, will have to be reinvented because they will function differently if they depend on renewable energy in the future. So we will need an industrial revolution, maybe a conjunctive upswing, so a long upswing of the world economy, because it has to be done globally. This, of course, is double-edged. It is green growth, and what we achieve in the end, if we are successful, is enormous. It would be enormous for mankind to get rid of fossil energy and lower GHG emissions down to zero, but it is also brown growth because there are new scarcities, land, silicon, or what you take. But I think it makes sense. The main instrument to achieve it, this green transition, is, according to most of the literature, that we raise the price for coal, gas, oil by a carbon tax, a tax or a trading system for licenses. So this would mean that very volatile prices of carbon-intensive energies, like the ones you see here since 1990, should grow steadily. I took here a trend line of 5% per year. If we could manage that, then the increase of prices could be anticipated, and it would be a great help for enterprises to include this in their calculations. We will need 5 industrial policies: agriculture and fishing, energy generation, industry, traffic, housing, on a global scale. Industrial policy is the policy of the day, of the next 20 years, 30 years, not so much macro policies, poor Keynesians. But it was Joan Robinson who said long time ago, we need structural Keynesianism. So Keynesianism plus structural change. And we have to apply this mantra to the conditions that we are now tackling with. We also need border carbon fees in order, because we have so many countries with some leading, some following. So we might need new tariffs. This is probably a rollback of globalization of trade. There's a new role for the WTO. Maybe if it does not work properly with global governance, we run into global price wars and perhaps even currency wars. So very, very delicate issue, to say the least. Now I run into ecological economics from the transition issues back to ecological economics. The basic idea put forward by the inventors of ecological economics, namely Georgescu-Roegen and later Daly, was to reach a steady state. Not a steady state in the sense of Adam Smith and the classics. All classics, as you know, believed in steady state, that at a certain stage of capitalism, stationary economy will pop up for other reasons, not for natural scarcity reasons or emissions or those climate change issues that we discussed today. So in ecological economic steady state is the bringing together economic stability and ecological stability, the latter meaning a constant flow of material or of throughput or of matter. Three synonyms, I don't know what it is, maybe Peter can tell me. So GDP is often taken then as a rough proxy for the flow of matter, but the mantra of Georgescu-Roegen was matter matters. Indeed, it does, but we have to quantify it and we have to aggregate natural resources, and doing this with a category of throughput is for me strange. And I found it not very convincing. You know probably that there was a conflict between Georgescu-Roegen. He was for degrowth because he saw that mineral resources are limited on the globe, and until they are, or when they are used up, then we run into degrowth or very low growth. Whereas Daly was in favor of zero growth. He proposed to control the throughput, to keep it constant or close to constant. He made three kind of strange proposals for zero growth. The first one was going for income and wealth redistribution. Okay, but redistribution of income and of wealth would probably increase consumption for obvious reasons. The second one is transferable reproduction licenses for women. And the third one is tradable licenses for throughput. I will not comment on the latter two. I can't understand them. They are outlandish.
Jan, you have 5 minutes.
Okay, so it is quite unclear from environmental economics whether we need D or zero growth. I think zero growth is totally unconvincing. So if degrowth, it must be the end of degrowth. So that would be the idea of hard sustainability. Now, after Daly and Georgescu-Roegen came few other schools, so to say. One is the ecological footprint research, which most of you know. Here, the currency, as they call it, for natural resources is global hectares. So it is land. We count land. I saw other proposals who count the use or usage of natural resources in kilogram and tons. I found it, well, to say the least, not convincing. The basic idea is that the biocapacity must not be less than the global footprint. And the footprint is the addition of all these footprints that each individual or each country has. In those calculations, I could go deeper into this. I find them enormous, interesting, but I find them, if you do not believe in the land measure and the calculation metrics which they use, they are problematic. And I think nevertheless, we can learn from them. And the most important thing, or which I found most important, is that the authors of this footprint international network found that 60% of the global footprint is caused by CO2. In advanced countries, even 70%. And if you add methane and other gases, it is probably more than 70, perhaps 80%, which comes from greenhouse gases. So we can reduce the global footprint, even if you want to follow the metrics with the land, with the global hectares, we would erase a great deal of environmental damage as counted by the footprint research. I have a better, a larger preference for the planetary boundaries approach from natural scientists. There is no ecological economist or any economist involved. You may know there are 9 biochemical boundaries for the globe, and the most important ones are the climate problem, so CO2 and methane mainly, and the biodiversity. So my clock says time is over, and I will come to an end very, very quickly. I like this. It is co or overlapping with the footprint research, and perhaps even with Georgescu and Daly to some extent, but it says nothing about zero growth or degrowth. You can't derive degrowth or zero growth from Wackernagel and others, or from Steffen and others. So my idea is indeed to go on the green growth issue, not forever, but for the next 30 years until mid-century. And then I jump now into the alternatives. My idea since very long is to impose limits, barriers on global consumption of key natural resources, so to speak, guard railings. And one of the guard railings, of course, would be GHG emissions, pollution, that have to come down to zero in an appropriate time frame. But other key indicators as well, maybe phosphor, maybe silicon, I don't know. Then we should reduce global GHG emissions down to zero, as I said, and preserve the global sinks, the oceans, etc. And within these limits, within these guard railings, we can have rising GDP. Perhaps we need zero GDP, perhaps we need less GDP. I don't know. It depends on technical progress, which we cannot foresee. I'm not so sanguine as Steffen that he just says technical progress will go in this direction. I don't know, it is open. And, but there might be technical progress. But it is also very likely that we can have growth, maybe lower growth, differentiated between countries. So I leave it open, and that is an evolutionary approach. I just say, I don't know, we don't know the future. But what we do know is that for the next decades, we have a goal. And this goal must be reached. And for this reason, we need to change technology, because with just dropping growth by 50% on the globe, which of course would lead to disaster and misery and poverty and hunger, this cannot be done. And lastly, just one word. If we would have to have within my guard railings zero growth, it would be capitalist minus capital accumulation, which is not identical with capitalism. It contradicts capitalism. Capitalism is not about semantics. It is a term not only defined by Marx, which includes accumulation and profit maximization. That is a regime change. That is a change of the economic order, of the global economic order. And it has to do with power, because the capitalists, especially those with the fossil energies, they have this power. So please don't downplay it as a just semantic change of the system. No, it is not. It makes a difference whether capitalists are only consumers or whether they use the money they earn for more money, as we have learned in the past 200 or so years. And by the way, if we open the economy and don't look at a closed economy, of course, capitalists will migrate to growing countries. And we have global capitalism nowadays. So global capitalism will take place outside the zero growth economies, and nothing is then improved for the planet. So zero growth in one country makes little sense. So capitalism is global and cannot be abandoned. Lastly, and I will not comment on this, I calculated this, and greenhouse gas emission since 1970, there's a break in the data. So look at the data from 1990. You see the increase. The main increase is the red area, China. And this is other emerging upper middle income countries. And this is what we have to tackle. And this is an extreme challenge. Thank you.